Hey everybody, this is Larry. I'm doing this problem as part of a contest, so you're gonna watch me live as I go through my dots as I'm coding. There'll be an explanation near the end, and for more context, there'll be a link below on the actual screencast of the contest. How did you do? Let me know how you do. Hit the like button, hit the subscribe button, and here we go. Uh, Q4, find the k-smallest sum of a matrix with sorted rows. Um, whew. Um, Yeah, so this one, I struggle. Right now I'm still reading the problem, reading the problem. My mind, I refreshed to see how many posts I made. I was like, wow, okay. But in my mind, I was just like, okay. Um, I think one thing I should have done a little bit is look at the constraint first, and I do it now. But I was like, okay, what are my tools, right? So I was thinking of dynamic programming for a little bit of like similar to the last contest of enumeration, but I was like, okay, no, that doesn't make sense. Or like I couldn't get the math to work. I did a lot of calculator like calculations of like 5,000 times 40 times 5,000 or some permutation to kind of figure out different types of possibilities. But at the end of the day, like I went through a lot of those cases and I just could not get it. Because so the one constraint that I did miss was that the k is less than or equal to 200. Uh, um, yeah, so I missed it. I totally like I know that's in my face and I've looked at it a few times, but for some reason I just kind of like it didn't tick in my mind. The k is less than or equal to 200. So right now I'm just trying to figure out different ways of brute forcing in a way, but using maybe dynamic programming as a crutch to kind of fix that. One strategy that I mean I'm going to fast forward a little bit or like skip ahead and click on the links below to kind of skip ahead with me if you like. Um, but the one strategy that I was thinking of at this point was was kind of the only thing that I thought maybe had a chance was some sort of binary search with okay, given a number, say example 4, say 12, can we count the number of sequences less than 12, and can we do that with dynamic programming maybe? But I still couldn't come up with that recurrence, so I end up spending a long time. Uh, Click on the link below. I mean, I'm going to skip ahead because I literally just thought about all these different dynamic programming things for like a good 20 minutes until I was like, oh, k is equal to 200. You are, Larry, you're a little bit, not sharp right now. I just woke up. That's my excuse, and I'm sticking to it. but uh, but yeah, once I saw that, I was like, oh, a lot more things become feasible. So skip ahead, and I will join you there. you'll know this one. Oh, this is 200, so I missed that part. Poop. Yeah, so at this point, I finally read the code correctly. I remember this being longer than it was, so I definitely, looking back, had issues with the implementation, but I was just thinking about, I mean, so at this point, I knew that I wanted to do priority queue, almost like, yeah, just one at a time, get put the next possible smallest number in the queue, because all the inputs are sorted and so forth. And that was kind of a hint. And I just kind of start writing out the template now that I'm like trying to think a little bit of it. I still worry a little bit about the the issues getting too big. So that's kind of what I do here. Yeah. So I started by I think right now you could see kind of some rustiness because I was just not sure how to write this code in a clean way. But I am at this point. I knew that I wanted to do priority queue, and I think at the time, yeah. Now I'm just slowly writing the queue. At the time, I was just thinking about like what is the worst case for this, right? The scenario, even with k is equal to 200, and I couldn't really. You could see me deep in thought, Larry, thinking about like all these things. Well, if you want to think about it, there's like I'm talking to my best friend to that corner, or maybe, yeah, to get the answer. No, I'm just kidding. Don't report me, please. But now Larry's deep in the other Larry's deep in thought, trying to think about all the possibilities for this one. But yeah, I still end up taking 14 minutes to implement this, so this is a little bit slow for me. For a couple of weeks, because I was just very skeptical the entire way um, about the timing, to be honest. Um, like, I think now, looking back, I am able to convince myself that and I'll explain that once we get there a little bit closer. Um, but at the time, I was just not sure, and I was rushing, not rushing, but I was like feeling a little pressure to kind of wanting to do this very quickly. Um, but yeah, I'm still, you could kind of see me still trying to figure out how to really implement this. It's a little bit rusty. Usually when I do priority queues, I do it with a fixed length of things. So I haven't practiced this variation in a long time. And I'm just trying to also, I don't know, I'm just a little bit rusty with the priority queues. I think that's, I mean, it is what it is. Uh, yeah, now I'm just, uh, so the idea what is pretty simple. It's just that it's almost like, okay, so now you're given m or n, I forget, but the number of columns, or sorry, a number of rows of arrays, and then you just take the first element because they're all sorted, and that's just smallest element. And then for next, just spread out to get, put, okay, what do we move the first index by one? What do we move the second row's index by one? And so forth, and then try to do all that. And here I'm probably just stalling, to be honest. I don't know why I'm doing this, where like it doesn't really matter. And just to get some compilation error, because I also, one thing is that I wasn't sure that line 7 was correct syntax, so that's why I was checking for it. But I was didn't really seem like it was necessary per se, the way that I'm doing it the way right now. But yeah, now I'm going for each index. Um, I don't know why I'm so. It's a little painful watching back, but that what's good about watching back is you kind of figure out where you're spending your time on, and there's no perception, there's no, it's absolute honesty where you're spending your time on, and it allows you to kind of figure out how to improve better. I think I don't know, like I've done priority queues many times, so that's not the issue. It's more that I was just not confident about this solution the entire way. I think that was my major thing for this. Um, but but yeah. And when I'm a little bit confused, I write very verbose variable names instead of one letter variable names, as you can see me do here. And you could calculate it. You could actually just do a sum. And this is not a big deal, but for performance, or I didn't even try to do it for performance. I just kind of do it for. I was also try. See, this is all messy in how I because I was still like trying to roll around the idea in my head. I think it's part of this so part of what I was not confident about and trying to test is that like, can you put arrays in priority queue in Python? And I wasn't sure because, for example, lists or arrays or lists are not hashable, but I didn't know. I wasn't sure whether it is priority queuable. So that's kind of essentially what I'm doing here. Uh, but yeah, and now I'm just trying to figure out because for some reason I thought it's possible that each array or yeah, each list could have multiple or just the variable lengths. Uh, but it actually turned out that all the matrix or all the rows have the same length. So I just like, okay, I could just do it that way. But yeah, very slow. Uh, I mean, I think looking back, I definitely spent time on things that like I could have been faster on this, considering that I knew the answer. But my implementation was a little slow today for this problem. Um, and a little bit rusty. You see me do one other thing that I just forgot about because I was careless or just not. I don't know why. I don't know. Sometimes you have good days, sometimes you have bad days, I suppose. And if one of my bad days, I still finish top 100, that's pretty good. Or even a little bit out of top 100, wherever I end up. Um, but yeah, but for this one, so I couldn't prove this at the time because I didn't want to spend time proving it. And even in the explanation, I don't think I proved it. But actually, fun fact is that I record this commentary after I record the explanation. So sometimes I do have a little bit more time thinking about it. So for this one, actually, it's good enough to only keep track of 200. Why do I spend 7 minutes more after this? Because I'm mostly done. But that's a little sad actually. Because if I finished now, I would have been still top 50, roughly. So I spent 10 minutes misreading, but I guess I was just really slow. Uh, oh, also I was doing something with. You'll see this next is I was doing something with the way that I wasn't sure was performant. Like I was saying, there's a lot of stuff that I was doing with this problem that I just had doubts on with respect to performance. But yeah, but you can actually use the pigeonhole principle because you're only ever gonna need the 200 smallest number. You can actually keep your queue less than 200. I choose 40,000 here because I didn't want to spend time proving, and 40,000 was just 200 square. So I was like, maybe each of those have like some weirdness or something like that. That gets me to because I wasn't. Um, Yeah, I don't know. I don't know what the actually. I don't know now that I think about it. I don't know if I can prove that as well. But because you may maybe have a path that goes in a very close way. But yeah, now I'm just running into because I renamed a few things and now I'm just doing silly things. And also, heap push requires the queue element. I forgot about that. Uh, this goes on for another 5 minutes, which like is how long most people would sell a lot of stuff. Um, yeah, and I was off by one. Um, Also, to be honest, some of that was I wasn't sure what it was a K index or um, what you call it. Uh, oh, sorry, zero index or one index. So I was like, huh? Because I didn't want to break out the loop. So I just want to print it out. Everything looks mostly okay. So like it was documenting the right way. So I was like, okay, maybe I was just off by one. But yeah, this process was a little bit slow. I should have recognized that this was off by one way much earlier, and I was able to would have been able to handle it much quicker. Um, but I don't know. I think I was just a little bit maybe tired as well, and that's like a because I was struggling on the hard problem a little bit. And something that doesn't get emphasized enough is that like the longer the contest goes, it does become an endurance contest, and especially for the harder contests. So you have to really, stay healthy, get sleep, and pace yourself. And yeah, you could. He is tired. Um, yeah, now I'm just trying to think about like all the cases and whether it gets more crazy. I don't know why I clicked there. No, that's here. But oh yeah, and here this is a way amateur mistake of just not keeping track of states. I was like, huh, this is not actually, yeah, I forgot about this. This is not even off by one. It's just like me being silly. Um, and now I remember this part, which is that I was like, well, I knew this. To be frank, I knew that this was not one. So what I'm doing right now is googling whether or how to hash a list. I know how to hash a list, but I was trying to figure out if there's uh, a efficient way to hash a list because if we're going to do a lot of these and queuings, I wanted to make sure that it runs in time. Because again, um, normally I would just like if there was a smaller constraints, I may hash it in a dumb way, and I did end up hashing it in a dumb way, as you'll see. But because I was really mindful about the performance, at least for now, that I was just a little bit preemptively, maybe a premature optimization, but it's hard to tell with these problems with the search space that could grow so exponentially that like and you don't know how close you are to the end sometimes, or like in terms of the time limit until you go through it. Uh, so yeah, But yeah, as you see, I hashed the dumb way. I was just trying to think whether uh, if there's a smarter way to do it. But I was like, okay, just do it first. My focus was just doing first, and then we worry about the performance if we get to it. And with that in mind, I am going to test the worst case performance. So yeah, and obviously this isn't even good, but that's okay. And yeah, I got the right answer, but I'm not confident about this because, well, I mean, I'm confident about the code relatively, and I'm just like, so I don't do it twice. Um, and also, autocomplete removed my close parentheses. That cost me like another 5 seconds. You laugh about this 5 second that I'm complaining about, but if I had 5 seconds faster, I would have been one or two rank higher. Uh, so yeah. So in this anyway, I knew that this was good, but now I actually have used like Seek or something. I need to write. I need to maybe invest some time in a test case generator. But yeah, I was just looking at the worst cases and just taking, and you see me literally typing from 1 to 40. So this took some bit of time. Um, but yeah, and then you also see me try to test the 40 case, N and M as you go to 40 case. Um, and that's pretty much the entire problem. I mean, I feel a little sad that I just misread for a while, but looking back, watching the live commentary, I did spend a good amount of time like just coding this, so there's no reason about it. But yeah, and you just see me try to do the end as you go to 40Ks. But yeah, thanks for watching the commentary. Stay tuned. Larry will explain the problems a little bit more in depth for each of them. And thanks for watching. Hit the like button, hit the subscribe button, and I will see you later. Last one. Find the kth smallest sum of a matrix with sorted rows. So this one, my biggest issue, I don't know why I missed. I think I just was focused on the N to the M part, and I just missed the 200 part, to be honest. Um, so that was a little unfortunate as a result, because I spent, I don't know, at least 15 to 20 minutes trying to figure out a general case. I was, and you could go back to commentary to kind of look at what strategy I did if it was the hard problem. Because if this was the hard version, I would have, because I thought about like, okay, maybe I could try like, oh, for say 12, how many combinations are smaller there, and then do a binary search, and then do that with dynamic programming or something like that. And I was trying to think about also different ways of doing dynamic programming, but all of them, like the math didn't really work out. But that's mostly because I just missed the 200 part. And I think I have to see where the timer is exactly. So in the comments, you'll probably, I'll probably talk about it a little bit more after watching it again. But But when I saw the k is equal to 200, I was like, oh, that's easy enough to brute force in a way. You have to still brute force it smartly, and that's what I did with a priority queue of basically, yeah. And I worried a little bit about the queue or the priority queue being way too big. So I did a little bit of hack that I couldn't really prove, um, which is that well, I keep track of the biggest number um, that's in a queue, and we only insert a number that's bigger than the biggest number in a queue if our queue length is less than 40,000, which is an arbitrary number. I got that by 200 square. I don't know if that's a foolproof number, to be honest, and I don't know how to prove. I mean, I have to sit back to think about how, like this, my idea was that there's some pigeonhole principle type thing, but I'm not sure that that's actually true, to be frank. Um, that was my gut logic. So yeah,